Hello and welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to use a feature or demonstrate the technique in just a few minutes. Today, we're going to look at a new option in Automatic Volume Meshing panel that allows you to specify a desired center point for the farfield shape when creating a block using AVM. Here I have a surface mesh for a drone geometry, and I would like to create the volume mesh, or in Pointwise's terminology, the block around the object. With my surface meshes or domains selected, I go to Create Automatic Volume Mesh, and then select Create Volume Mesh Boundaries. Now, as you enter the AVM panel on the Global tab, you'll see that you have the option for the type of farfield mesh, as well as the shape, whether a box, a cylinder, or a sphere for the farfield. In the earlier iterations of the Automatic Volume Mesh tool, you could choose how the farfield extents would be drawn relative to the shape, whether you want to draw the extents relative to the faces of the extent box or relative to the centroid of the extent box, and the latter would happen to be the default option. Now, in the latest release of Fidelity Pointwise, you now have a third option, which allows you to specify an arbitrary location for the center point of the farfield shape. So let's look at this option. Here, I'm choosing a box for my farfield shape, and I'm just going to keep the length, width, and height values as already prescribed. However, let me choose the third option for user-specified center point. And as you can see, this enables an XYZ field to enter the location of the center point. Now, a few very important points to make here. First of all, since the algorithm has automatically detected a positive X symmetry for the geometry, the X coordinate of the center point is always going to be anchored to that plane. So keep that in mind. Secondly, the center point can be updated interactively by just simply selecting points in the display window. And lastly, depending on the prescribed length, width, and height for your farfield boundary, moving the center point may actually cause the extent box to no longer encapsulate the primary selection, which would produce an invalid topology. In that case, the appropriate arrows in the display window will be rendered in red, as you can see here, and you also get a message printed in the messages window that will tell you the minimum required offset for each invalid extent. Here, you can choose a different center point or simply change the dimensions of the farfield domain for the error to go away. Thank you for watching. If you like this video, be sure to click the thumbs up button to subscribe to our channel for more videos like this. And if you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a pleasant Tuesday.